Welcome back to the Medical OS Masterclass. I'm Dr. Trevor Turner. Today, we're diving into one of the most critical architectural rules for clinical AI: how to build institutional memory without creating a dangerous shadow chart. Your clinic needs an AI colleague that remembers your referral patterns, formatting preferences, and escalation rules, but the moment it starts remembering patients outside the source record, you may have built a shadow chart instead of a safer workflow. The patient record needs one canonical home, even when the workflow has many moving parts. That is the rule the architecture must enforce. In this episode, you will learn the difference among sol.md, memory.md, user.md, and a session store, how to use stable, context, and volatile prompt tiers, and how to enforce the hard clinical rule that patient facts are retrieved from the EMR or file source for each task, rather than retained as agent memory. You will also see why a useful session history needs purpose, retention, and access boundaries. When people say an agent learns, they often imagine a model training itself on every interaction. That is not the useful concept here. Hermes can accumulate carefully selected operating knowledge around the model, facts about how work should be done, preferences about how results should be presented, reusable procedures, and a searchable history of prior work. The model itself is not becoming your clinical database. Sol.md is the agent's identity and non-negotiable operating posture. For a clinical orchestrator, it might say, the EMR is the canonical patient record. Retrieve data only through approved tools, and stage every output for human review. Memory.md stores durable institutional facts, like referral packet formats or image availability checks. User.md holds your working preferences, like lead with uncertainty or use concise briefs. A session store is the audit trail of a specific interaction, not a permanent archive. Hermes assembles these inputs in 3 prompt tiers. The stable tier is durable policy, context is the current playbook, volatile information is the case in front of you. Patient facts belong in the volatile category and should be pulled from source systems only when the task has a legitimate approved need. A skill is a versioned executable SOP or procedure, not a patient fact. This separation allows the system to improve its process while keeping the record where it belongs. Consider a small regenerative medicine clinic that wants a pre-visit agent to prepare complex consults consistently. The practice has learned that referrals arrive through several pathways, and MRI reports often appear before images. Those lessons are appropriate institutional memory. The agent's sol.md states that all clinical work begins read-only, and the physician remains the final decision maker. It prohibits unauthorized chart updates or medication changes. Memory.md contains condensed clinic conventions. For example, for external orthopedic referrals, verify report and image availability separately. User.md might say, lead with the source gap rather than burying it. Now a new patient is scheduled. The agent does not receive a stored patient synopsis. It calls the approved read-only get encounter context tool. The EMR returns the current context necessary for this task. Suppose the agent finds a 2024 MRI report, but no image study. The fact is included in the draft with its source, date, and uncertainty label. It is not written into memory.md. If the agent finds retrospectively documented relief but no contemporaneous measure, it flags it as a source gap. At the end of the task, the system may propose a durable workflow improvement, like adding a source gap check for images. That proposal is safe because it refers to procedure, not patient content. This approval gate matters. A background process cannot decide that a workflow preference is now clinic standard. Version control provides the correction path. A proposed change gets a version, a reviewer, a rationale, and a rollback option. The goal is to make work reproducible and reviewable while keeping the patient record in the system designed to hold it. Stable tier, roll. Context tier, SOP. Volatile tier, current facts. That is how we learn without accumulating an ungoverned duplicate chart. The most dangerous memory failure is contamination. A clinician corrects one patient's fact and the agent treats it as a clinic-wide convention. That is why patient facts must not be written into institutional memory. Stale policy is another risk. Every durable instruction needs an owner and a review cadence. Finally, no prompt file can substitute for technical controls. Do not retain PHI is a policy, but enforcement requires narrow tools and logging. The rule is that the accountable physician approves any durable change to sol.md, memory.md, or a clinical skill. Patient-specific information is never approved as agent memory. It is retrieved from the canonical source for the individual task. If the agent cannot prove the source, timestamp, and permitted purpose, it must not place that fact in a clinical draft. No convenience exception converts a remembered fact into a verified source. Remember the process. Retrieve the patient facts. Never use agent memory as a shadow chart. If the boundary cannot be audited, the fact is not ready for use. This week, make 4 columns: identity rules, institutional preferences, physician preferences, and patient facts. Sort 10 statements from your workflow. Always flag an unavailable MRI image is a preference. A patient's procedure date is a source record. If a line does not fit the first 3 columns, keep it in the patient's source record. Small reviewed memory is more valuable than a large, opaque accumulation. This video is for educational purposes only and does not constitute medical advice or legal advice. Any implementation of AI agents in a clinical setting must be reviewed against your HIPAA posture, state board requirements, and professional judgment. The physician remains the accountable clinical decision maker. Join us in the next episode where we turn an approved SOP into an executable skill.